mind, as you know, the topic of this conference is tackling big data rather from biometric to infra-action. So we are trying to propose a very peculiar turn to the critique of big data and also to the potential responses to it. We will see throughout, and hopefully together, how we develop this. So now it's my pleasure to introduce Kevin LaGrandeur, who is one of our associated partners, who just hosted a forum in New York, a network forum in New York, and who will now present an iteration of his research in relation to networking. So welcome.
Can you place this so I can do all the slides? Okay, can you hear me? I guess I have to talk directly into this. Okay, the project I'm about to discuss, Cybersecurity and Digitized Human, is meant to be a starting point for some of the discussion to follow this conference, this Unconference. But I want to note that it's a new project of mine and my colleagues, so I'm still working out these ideas. For this reason, I'll look forward to further discussion and suggestions about them up here later. Some of my colleagues at NYIT and I are investigating ways to collaborate on the ethical dimensions of two projects that are already underway at our school. This work's relevant to Metabody in two ways. The first project I'll describe later in this presentation uses body movements and rhythms, biometrics, to identify users. This is relevant because it's a codifying and data encoding of what otherwise would be spontaneous human movement. What are the ramifications of this, is what I want to ask. The second project I'm going to talk about also depends on codification of human behavior. That is, how they behave on a network, how they move about when they're within the network, and what actions they try to take in the network. I've teamed with these computer scientists at my school to investigate the ethical dimensions of their projects. Both types of movement, the first project is literal movement, and the second is virtual movement, are being codified and digitally evaluated. And the second project I mentioned has very possible consequences of intrusiveness into users' privacy, and I'll talk about that in a few minutes. All of these eventualities are of central concern to Metabody. So the first of these projects is funded by the US government's Defense Advanced Research Projects Agency, which is called DARPA, most commonly. And it's under their program to replace passwords with what they call active authentication. Here's how they define this program of active authentication. The current standard method for evaluating a user's identity for authentication on an information system, and I'm quoting here, requires humans to do something that's inherently unnatural, to create, remember, and manage long, complex passwords. Moreover, as long as the session remains active, typical systems incorporate no mechanisms to verify that the user originally authenticated is the user still in control of the keyboard. Notice the word control there. Thus, unauthorized individuals may improperly obtain extended access to information system resources if a password is compromised or if a user doesn't exercise adequate vigilance after initially authenticating. So far so good. These goals seem to be very focused on the user's well-being. But then we run into some goals that are a little more questionable. And I'm going to quote some more here. This program focuses, validating the identity of the person at the console that focus on the unique aspects of the individual through the use of software-based biometrics. The program focuses on the behavioral traits that can be observed through how we interact with the world. Specifically, just as when you touch something with your finger, you leave behind a fingerprint. When you interact with technology, you do so in a pattern based on how your mind processes information, leaving behind a cognitive fingerprint. So, bits of this statement, this last one, seem a little frightening, and I'll come back to this later. First, let me describe the specific project my colleague's doing to contribute to this idea of continuous authentication. The project my colleague Kiran Balagani and his collaborators from Louisiana Tech and City University of New York are developing as an alternative to password-based methods of validating computer users is entitled Investigating Cognitive Rhythms as a New Modality for Continuous Authentication. It uses biometrics, specifically the unique rhythmic movements users make on their smart devices and peripherals, like their keyboards, their mouses, their mice, and their smartphones, in order to identify each user. These movements can range from the way they move their smartphones to the way they type and interact with their keyboards. The basis of the project is that no two humans make the same movements in the same way because movements are uniquely key to the way each person's brain processes and transmits signals. So, the team working on this project are trying to fashion an algorithm that can learn the particular sets of movements that a person makes with a smart device in order to authenticate who the user is. Now, this would replace the task of typing in a password. In the case of a smartphone, for example, a special algorithm in the device would, by means of the accelerometer that's built into the smart device, the accelerometer is the sensor in this that when you tilt it, it moves the screen for you. You can tell where it is in space. So it's going to use the accelerometer built into the device to sense and learn the pattern of movements that any given user makes while carrying the phone, and then constantly authenticate while the user is carrying it. As soon as the user puts it down, it ceases to be authenticated and it turns itself off. So when I pick up the device, it turns on, it senses it's me because of the way I move with it, and automatically turns on and authenticates me. It's a password. So it compares what I'm doing in real time to a baseline that it's recorded for me. So whenever the user wants to log in, they simply pick it up and put it down when they don't want to use it. The aim is to develop a scientific method that's both simple for the user and free of human error to continuously prove the identities of computer users. The findings could be used to validate user identities for government computer systems. This is what DARPA would like, and eventually perhaps commercial sector as well, the business sector. So the other government-sponsored project is a cybersecurity project that uses decoy files to detect intruders on an internet system. When an intruder is detected, they may be punished in various ways. My colleague John Voris, working with a team on this DARPA project and the rest of the teams at Columbia University, recently developed a kind of security prototype that enables a machine to deceive an intruder by planting fake booby-trapped files into a file system. That is to effectively lie to the intruder and see if that person takes the bait. Then it decides, the computer decides, or the program decides by using computerized behavior models, whether it should take countermeasures against the person. The way this software now works is based on setting up false data as decoys. The intruder would trip this wire and cause a problem, and presumably legitimate users would know that these files were decoys because they work at this place, right? So the logic goes, if somebody tries to open or download one of the decoy files, represented by the X files on the screen, he or she must be an intruder. The software could then decide, using the behavior models mentioned previously, to take punishment measures, such as automatically calling police with the intruder's identity, or other things. So let me move now to ethical issues that all of this raises. First, as I said before, we've only just started working on this project and my time's short today, so my ideas here are just in the early stages. I'll look forward to further discussion and suggestions. My view and that of my colleagues is that such cybersecurity protocols often dance a fine line between effectiveness and ethical propriety. In the case of the first project, identifying users continuously by way of cognitive rhythms, DARPA's idea of identifying users by codifying, quote, a pattern that's based on how your mind processes information and converting it to a cognitive fingerprint may strike some of us as kind of dehumanizing and frightening, a way to characterize spontaneous individual movement, perhaps like films such as The Matrix, kind of a nightmare. However unsettling this might seem in a philosophical way, however, Dr. Balagani and I just can't see an ethical downside in terms of tangible normative ethics, that is, day-to-day ethics. The smart algorithm that learns your movement patterns does so to protect you and your devices. Yes, it records your movements and digitizes them, but a password essentially does the same thing. That is, it's a recording of your cognitive activity when you create the password, but it protects you a lot less effectively than the new system would. To give another example, this algorithm would be similar to what physicians do in their offices. A doctor records health information specific to you in order that they may protect you from disease more effectively. But they still have your data. In terms of normative ethics, there's no clear harm being done to anyone and much good to the user. There are clear practical ethical downsides to the second system, however. If intelligent systems are increasingly called on to decide who's an intruder and who's a legitimate user, and if the machine decides the next question, whether and how much to punish that intruder or user, then the question is this a proper use of technology? How much, for instance, should the intelligent systems be allowed to impinge on privacy by doing such things as automatically taking and sending a picture of the suspected intruder to police, or worse? Because that's one of the options, is that the software can automatically take your picture through the webcam of whoever's the supposed intruder and then send it directly to the police station. Deceptive tactics, given that this is similar to what law-breaking intruders do. What if a legitimate user makes an honest mistake and clicks on a decoy, triggering an emergency intruder response? How certain do we need to be about whether the user is actually an intruder or just a legitimate user who's made a mistake before the system and its human controllers respond? How far should that response go in identifying the user or sending his information to someone else or to some other system? The protection of users' privacy is obviously an important concern here. However, as one can see from what I've just said, the development of such software is in itself also troubling development. Unfortunately, the simple fact is that the United States government, and most likely other governments, is already making this software that I'm talking about. So, given that the horse has already left the barn, and it's too late to close the barn door, my colleagues and I see an urgency to move from debating the ethics of whether to make such AI, because it's already being made, and propose some ethical ways of governing that AI, ways that are also practical. One proposal we have, and I'm going to end with this here, one proposal we have to resolve this issue is to find a way to program safeguards into the software. Right now, the software that governs this sort of security protocol is somewhat rough. It only allows for basic identification of hits on decoys, and then binary yes or no countermeasure decisions. Yes, send it to the police. No, don't send it to the police. My computer science colleagues and I propose to improve this, and we're trying to get grants to do this. Our goal is to make this type of system both more robust and more ethical by first exploring ethical problems such as those I've mentioned already that pit user privacy against security, and then second, determining thresholds that might be used to distinguish severity of intrusion in a more fine-grained way than is currently possible. And then also we seek to determine which types of ethical systems might be used to improve this sort of machine decision-making with regard to escalation and response. Possibilities for this include, for example, decision trees based on Kantian deontology, which entails strict rule-based trees of decision trees, or utilitarianism. Or alternatively, genetic algorithms that can provide for less predictable reactions but greater evaluative diversity by the system, and developing more robust software that would allow the machine to make finer-grained decisions about which responses to take and when to take them. And I'm going to stop here and throw this all out to everybody else and to Jaime. Jaime will be talking next, and maybe he'll want to touch on some of these things. Thank you very much.